Recommendation 1 in the Teaching Strategies for Improving Algebra Knowledge in Middle and High School Students Practice Guide calls for using solved problems to engage students in analyzing algebraic reasoning and strategies. Solved problems, that is, examples that show both the problem and the steps used to reach a solution to the problem, can help all students access algebraic concepts more easily and support students' conceptual knowledge, procedural knowledge, and procedural flexibility. In particular, solved problems can support students' transition into the abstract thinking that algebra requires. Compared with elementary math work like arithmetic, algebra requires students to solve problems that are not always grounded in real-life scenarios. In addition, algebra problems are often longer and more complex, so concrete objects and counting strategies are typically less helpful than in arithmetic. Algebraic reasoning requires students to process multiple pieces of complex information at once, which can take up a lot of space in students' working memory. When you use solved problems during instruction, students see the problem and the solution steps. This can help them better learn new concepts because their working memory is not burdened by trying to generate the solution steps themselves. Research shows that analyzing and discussing solved problems can help students develop a deeper understanding of the problem-solving process and can support their critical thinking. Guiding students to analyze common mistakes in incorrectly solved problems can also boost learning and help students avoid these mistakes. In this video, we provide an overview of this recommendation and the 3 suggested steps for carrying it out in the classroom. To help students analyze solved problems, you can ask them to describe the steps that the problem solver took and the reasoning they used. Some discussion questions you can ask include, what were the steps involved in solving this problem? What did the problem solver do first? What did they do next? Why do the steps work in this order? Can anyone think of a different way to solve this problem? And will this strategy always work? Why or why not? You can provide prompts that students can use to guide discussion in small groups or pairs. You can also ask your students to notice and explain different aspects of an algebra problem structure. For example, you can ask students to describe the quantities, operations, and relationships present in the problem. This can improve their ability to recognize different problem structures and to understand the reasoning behind different problem-solving strategies. When incorporating solved problems into a lesson, select problems that align with the lesson objective. Solved problems can come from curricular materials, current or past student work, or student work from other teachers' classrooms. Have students examine the solution piece by piece, prompting them with specific discussion questions that illustrate the reasoning behind each step of the problem-solving process. Or you can have students analyze a common mistake in an incorrectly solved problem. This strategy has been shown to be particularly helpful for students with low prior math knowledge to understand and avoid common errors. In this example of a system of equations, the teacher has chunked the solution into 3 pieces and added an example of how to verify the solution. The teacher can then prompt students to discuss what Jada, the problem solver, did at each phase of the problem-solving process and why. This can help students understand how to solve systems of equations without overburdening their working memory. In addition to using solved problems in whole class discussions, consider having students work with a partner or in small groups to analyze solved problems by using guiding questions. You can provide students with a solved problem and ask them to discuss each guiding question with their partner. Consider using incorrectly solved problems, as research suggests that it can be particularly helpful for students when you include problems that illustrate common mistakes. Sharing incorrectly solved problems also increases student engagement, as they love to find the mistakes made. In this example, Luis made a mistake when solving a linear equation. In pairs, students discuss Luis's first step and whether it was appropriate, Luis's reasoning, the mistake, and a strategy that could be used to correctly solve the equation. After students finish their discussions in pairs, bring the whole class together to discuss the problems further. Be sure to engage students in a discussion about Luis's reasoning, including why the mistake was made and how similar mistakes can be avoided. When I implemented this recommendation in my classroom, I was worried that showing incorrect problems would confuse students. I don't want them to think that these were examples of good problem-solving strategies. I decided to clearly label incorrect problems with a large red X every time I displayed them to my students. In addition, I often presented incorrectly solved problems next to their correct counterparts, which I marked with a large green check mark. Engaging students in a discussion about each step of the incorrectly solved problem helped to clear up any confusion. Each time, we thoroughly discussed the reasons why the mistake was made and how it could be avoided. Analyzing incorrectly solved problems helped build my students' understanding of common mistakes and of correct problem-solving processes. I also noticed that my students started to confront and correct their own algebraic mistakes with less fear and more confidence than they had previously.